Welcome to our bonus episode of Women in Science. Today we'll be talking with Dr. Roberts about her research.
Well, I started with an undergraduate program in biology, and I was always interested in diseases, particularly of the brain. So I worked for a little while afterward and then decided I wanted to get my PhD. So I got into an anatomy program and studied epilepsy, and then did my postdoc in Boston, studied Huntington's disease.
Oh, okay.
And then I got a job offer in Maryland at a psychiatric research center. And they had started a human brain collection, which was really neat. And they had purchased an electron microscope and wanted an anatomist to come and manage the brains and do electron microscopy of them. So it was an incredible opportunity, because what you want is you want to get your own niche in science and do something that no one else is doing and kind of make a name for yourself in a given area. So I started in Maryland and was there 17 years. And by the time I left, we had over 900 brains in the brain collection. And so I just ended up continuing my research in schizophrenia for my whole career after training. And also because nobody does electron microscopy post-mortem brain really. It's difficult to get the tissue in time and fashion. So there's not a lot known just about the ultrastructure of the normal human brain. And so whenever I do a study, there's always the normal component that's interesting and new to compare to other species, and then the disease element to see what we're finding. So still, there's only one other researcher in the world that does post-mortem electron microscopy quantitatively in schizophrenia, there in Russia. And we have to get the brains under 8 hours post-mortem interval. Squeak it up a little. We're always trying to push the limit on that. So when I first started, people thought, oh, you can't do electron microscopy in post-mortem tissue. I said, well, you bought this microscope and hired me, so let's try it. And 26 years later, whatever, here I am.
So cool.
This is an electron microscope, and as you can see, it needs its own room, and there's equipment adjacent in the adjacent room there, coolers and chillers and so forth. So this allows us to magnify things really incredibly huge. This is in the opposite direction. It can give you a feel. If you took a pea and magnified it to the size of a football field, that's what the electron microscope can do. So cool. So we look at things a lot smaller than peas, and I'll show you how we get that tissue prepared in a minute. And this is a transmission electron microscope, and we usually examine tissue at about 25,000 magnification, or 30,000. If you're looking at other things, metals or crystals or whatever, sometimes you go up to 100,000. But we don't do that with the brain material. And this has to be prepared in a very special way. And then we get digital pictures that we quantify various aspects of the number of mitochondria, the density of synapses, the size of things, whether or not they look ultrastructurally intact or damaged, and that's the basis of a lot of our research. This is a picture here of ultrastructure of the human brain. This is a substantia nigra.
Okay.
And it contains the dopamine neurons that project to basal ganglia cortex. And dopamine is a major factor in schizophrenia because all of the medications block dopamine receptors. So these circles here are myelinated fibers. And so I've had grants from the National Institute of Mental Health over the years to look at various brain regions. And we just got an R21 funded to look at white matter tracks, because not only are different parts of the brain abnormal, but the connectivity between them is as well. So that's a project that we're starting.
Very, very cool.
We look at different areas of research in the field. So the imaging people study life. And so they can determine a part of the brain that's defective either during a task or at rest. And then we can use that information and go to that brain region, post-mortem tissue, and see what could be causing their findings. So if there's a problem with axonal integrity between two areas that shows up in the imaging, we can look at that, and that's what we're doing with the electron microscope and other levels too, to see, is it the axons, is it the myelin, is it the cytoskeleton, is what could be causing this abnormal synchronous activity between brain regions.
Very, very cool.
You need self-confidence. You need to be assertive. And you need common sense and listening to the bosses and the people who have more experience. Just because they say something you don't like doesn't mean it's not true.
Yeah.
And so,
sadly.
Right. So if they say, "Oh, I think you should do this," and your initial thing is, and stop and think, because they got there for a reason, and they have the wisdom and the years of experience ahead of you. So, they could be absolutely wrong, and then that's the time to not just cave in, but so you need that balance, and don't let yourself get bullied in any way, either because you're a woman or because you don't want to work 60 hours a week, or and just do your best and do something. Get into a field that really makes your eyes light up. And then it'll be interesting. Like today, I came in long weekend, and my graduate student paper is under revision now. So it's not accepted, but they want to see some modifications, which when we looked at it, would be very easy to fix. So we're really excited.
Oh, so that's always a happy thing.
Yeah, and then we put together this grant. It's really exciting. And she has some data today that just is really exactly what we hypothesized, which actually doesn't happen at least half the time. So
as often as you want it to, it doesn't happen.
Yeah. So we're onto this new path that's no one's really looked at. It looked here or there or somewhere else, but no one's put it all together. And this is what we're doing. So it's really exciting. And to get this this data is super cool. So awesome. You want to also choose a mentor that not only can teach you, but will not drive you out of science. And so
I feel like it's almost an experiential quote there. Almost. It just has that kind of
Right. So, for instance, when I was in graduate school, my mentor was family-oriented.
Okay.
You know, he went did work on weekends. He got Javits Awards, which are prestigious. He had a long and nice career.
Yeah.
I just went into his lab and moved on to another lab for my postdoc. A friend of mine wanted to go into the lab, somebody who's more well-known, famous. And she thought she would learn more than I would because
Better title, better knowledge of everything.
And he was so mean and so nasty that it just soured her on science. And so I think matching your personality with your mentor is really an important thing. Because if you get somebody that's a slave driver and burns you out, I know so many stories of that where, PI will just make people work so much, expect them to come in at 8 o'clock on Saturdays for lab meetings and stuff like that. Wow. That they just run screaming. And so that kind of person is famous, but abusive. Yeah. And not all famous people are abusive. But you have to...
There can be that possibility. You have to prepare yourself.
So, when I was in Maryland, I had a wonderful, set of colleagues, lots of laughter, collaboration. And here is a fantastic place in terms of the student population. It's really stellar. And the core facilities. And, I could get an electron microscope. So sometimes there'll be the unexpected. And that's not just for women, but,
anyone going
anybody. You think, okay, I'm settled here, and then all of a sudden something new comes up. And it's an incredible professional experience, and you end up moving somewhere else. So, and I guess another thing is for women in science, as well as just scientists in general, a lot of times you have to do long-distance relationships because you'll meet somebody, of course, in the lab, because it's where you are most of the time, or in school, and so just be patient. The jobs will come together at some point, or somebody makes an adjustment, but that's very common. It's a problem for people to deal with, but it somehow it works out. It's just may not work out exactly in the time frame you're hoping.
I am so grateful to Dr. Roberts for spending her time with me and sharing her wisdom. What a wonderful woman to look up to. Thank you for joining us for our interview today. See you next time.